Alright, in this video we're going to be talking about field initializers. And a field initializer is a little bit of code that you can have execute when an object is instantiated, but before the constructors are invoked. So it's a way to sort of give your fields some information before anything else has access to them. So I'm going to go ahead and fire up a new project. And field initializers are only valid, or instance field initializers, I should say, are only valid on classes. A structure cannot have a field initializer. So for example, if I were to say structure my struct, do private int x equals 10, you'll see again there.
Yeah.
Non-static construct member cannot have an initializer. But if I were to change this over to a class, or to write a my class, this is valid syntax. And what this is doing is this is saying, when you instantiate my class, before any of the constructors are invoked, go ahead and set this field. And I can prove that with an interesting little example. I can write a printer object, and I can say when the printer object is instantiated, go ahead and write out to the console. So I'm going to go ahead and delete this my struct example because it's preventing our program from compiling. Then I'm going to make a printer object, object1 equals new printer object. And I'm actually going to pass in a string parameter into this so that we can kind of see the flow of execution as we talk about when field initializers are actually called.
Okay.
So we'll say object1 init. Then we can go ahead and do another printer object, object2, and do not give it a field initializer. Instead, we're going to create a parameterless constructor and say object2 equals new printer object, and I'm going to pass in object2 in it. Now if I were to go ahead and instantiate my class, and prevent the program from closing and run this, what we'll get is interesting. Object1 is initialized, and then object2 is initialized. That is because field initializers are, every little bit of this code is simply appended to, I guess you could say, the construction process, or prepended to, sorry. So all of this code that you specify in a field initializer will be run immediately before a constructor.
Okay.
Any constructor. Now, this also has some very important sort of considerations to keep in mind, is that because these are being run before the constructor, there's no way to access this. So if I were to say private int x, or private int x1 equals 10, and private int x2 equals 20, and then I were to say object1 init plus x1, you see we get an error.
Yeah.
Cannot access a non-static field x1 in static context. So you see that this is being actually invoked outside of any class initialization. But what's interesting is if we were going to go ahead and do the same thing to here with x2, we will get the expected result and no compiler error. That's because x2 is being initialized before this code happens.
I see.
Now, field initializers are generally, whether or not to use a field initializer or a default constructor is generally a matter of preference. In certain cases, you must use code instead of a constructor instead of a field initializer when you have to access other members. As a matter of style, I generally avoid field initializers for some very strange behavior that we're about to see. So I'm going to go ahead and say console writeline, my class constructor. I'm going to say my child. We're going to do a private printer object, object3 equals new printer object, object3 init, my child, object1 init, my class, object2 init, and then just say plus my class. And then we're going to add a constructor here to my child and say console.writeLine my child ctor. Now, under normal circumstances, if I were to ask a person who didn't previously know this behavior what the output of this program should be, they might say that my class or object1 initializer will happen first. Then my class ctor will happen. Then object2 initializer will happen. Then object3 initializer will happen, and then my child ctor will happen.
Mm-hmm.
Because I mean that would make sense. Like constructors are always invoked from the least derived type to the most derived type. What I'm about to show you is that this is not true for field initializers. If I go ahead and hit F1, we'll see some interesting things.
So we're not hitting object 3 at all, it looks like.
No. Oh, yeah. Of course we're not. We're not instantiating my child. Yeah, I was looking at them. I was like, did I forget how to write C# or something?
You did. Just for a second, you did. It's okay, though. Continue.
Okay. So we see printer object ctor object 3 is invoked first.
Mm-hmm.
Then my child ctor is invoked next because, of course, we're not inheriting from my class. Wow. Okay, ignore the last 10 seconds, and what we have is we have two classes, one inheriting from another, and we're instantiating the inherited class. So let's go ahead and actually get the output that I was expecting.
Okay.
There we go.
So there's 3, and then 1, and then 2.
Yes. So 3 happens first.
Okay.
This field initializer happens first.
Because we're starting off by calling on my child, so that's the first place we go to.
But the interesting thing is that constructors behave the opposite way.
Right, exactly.
And you'll see that because my class, this code, happens before this code.
Mm-hmm.
But this code happens before this code.
Nice.
And there is actually a reason the C# compiler team did it this way, and I personally don't buy it whatsoever. Their point is that in the case of a read-only field, they want to make sure that all read-only fields are initialized because you might invoke a virtual member within the constructor of your least derived type.
Okay.
It's very stupid, basically. I don't personally. Very, very strange behavior that might actually hurt you sometimes.
Nah, tell us how you really feel.
Well, okay, let me just go ahead and demonstrate what they were thinking. Let's say we have a protected virtual void something. And then that virtual void something is invoked inside of this constructor.
Okay.
And then we override it up here. So we do protected override right here, and then we say console.writeLine. And if we run this, you'll see that this overridden is invoked during the myClass construction. But what the C# compiler team wanted to happen is if you have a virtual function that is being invoked from a base type, they wanted all of the fields to be initialized before this code executes.
Okay.
So that's what's happening here. All of the fields of this type are initialized when this code is being rendered. Now, the problem with this code is it's very ugly and it's very dependent on how well the person really understands the process of field initializers and construction. Generally, I would very much completely just say that you should never do anything like this. And you'll see even ReSharper is telling me virtual member calling constructor. So to make it a complete non-issue, generally what I do is I avoid field constructors and I never call a virtual member from within a base type.
Okay.
The last thing, or in addition, we have static field initializers, which behave a little bit differently than everything else. And static field initializers can be placed on classes and structures with the same behavior.
Mm-hmm.
So if I were to go say public static int static1, actually hold on, let's call this printer object, static 1 equals new printer object, static, and go ahead and run this, you'll see that the static is being invoked the first time that or it's being invoked immediately before the constructor of my class is being invoked.
Mm-hmm.
So static field initializers are virtually identical to instance field initializers in that whenever the static constructor would execute, static field initializers execute before they do.
Okay.
And so you'll see that behavior when you reference a static a static property or static field with a field initializer. You'll see that that code then gets executed.
Okay.
So really, that's about it.
All right. So is that everything you wanted to talk about in terms of these field initializers?
Yeah.
Okay, so that will wrap things up for this video. Thanks a lot.